My name is Erik, and this is a presentation called Rapid Prototyping with Solr. One of the reasons that I really like giving this presentation is to show simplicity in terms of getting data into Solr, and also in terms of being able to display it to users and stakeholders, and keep that whole process very simple. We have a lot of presentations here that talk a lot about the complexities and solving a lot of very complex problems, but we have to kind of start simple to get the data into the systems. So in this presentation I'm actually going to show several different examples of getting data into Solr and then being able to instantly turn it around and give a presentation of that. And then I'll go through some tips and tricks in how to go about doing that sort of thing. My background, I work at Lucid Imagination. I co-authored the Lucid in Action book, and I'm also a committer on the Lucid project, as well as a Apache Software Foundation member and a PMC member of the Lucid top-level project. Why prototype? What's the rationale for this presentation and for the technique in general? It's very often the case that you're asked to build a search application and on a short timeline, and you want to be able to take the data, get it into a system, and do something with it very quickly. Another great thing that you can do with this sort of technique is get buy-in from stakeholders. If you're using perhaps a commercial search engine and you're looking at replacing that with something cheaper, with something more flexible, what you can do is simply prototype doing something with Solr and see if it fits the bill. Another aspect of this is the user interface. I'm a big believer in the user interface actually is the application itself, and wanting to get right to the user interface once the data is in the system. There is some prior art to this presentation in general. I want to call out Chris Hostetter's amazing work that he's done with the blog series that he's been putting on the Lucid Imagination blog. There's a link to it right there. He has taken the internet speculative fiction database and iterated through a number of steps in getting the data into Solr through various mechanisms, using the data import handler, and then iterating through all the way up to migrating from Solr 1.4 to Solr 1.3.1, and being able to, he even went to the getting a user interface up and running with it. And I've actually also done this presentation. This is the fourth time I've actually given the same titled presentation, but every time I've done a different data set and I've done slightly different user interface type effects there. So what I'm going to do is I'm actually going to walk through these previous presentations kind of briefly here to show you what can be done. Okay, so last year at our Lucid Eurocon, the few days prior, and another reason that's great to give this presentation is it allows me to procrastinate and build this thing at the very last minute, and because it is rapid prototyping. I was brainstorming what to do for the rapid prototyping presentation earlier in the week of our conference, and our conference organizers were scratching their heads about how we're going to go about giving choosing random people, attendees, for prizes. So that got me thinking that if they gave me the data for the conference attendees, that I would be able to quickly build an application that allowed them to pick someone out of that. And along the lines there, I also wanted to get the data in and be able to do some faceting on the countries that were present at our conference. And so they sent me an Excel spreadsheet of the conference attendees. It gave me the first name, last name, the country of origin for the attendee, as well as the company name that the attendee was from. So just basic information there. And Solr has a CSV update handler. It makes it very, very convenient for getting data into Solr. So it only took a couple of minutes to be able to get this stuff into Solr. There's dynamic fields that are available in Solr, so you can simply leverage that without even changing the example schema and be able to bring data in. And then over the course of kind of fleshing that out, I adjusted the schema a little bit to have better field names, and then I tweaked the CSV import process to do a few things, such as map countries. There was an attendee who identified themselves as from Great Britain, but most of the people identified themselves from the United Kingdom, so I wanted to normalize that data, and the CSV update handler actually allows that, and you can see that from the URL there to bring the data into the system. Also, I was able to very easily adjust a configuration in the Solr config file for the /browse request handler, which is something that comes built into Solr now, and very quickly get a user interface up and running with facets, with search results, and I then iterated and added a few whiz-bang UI effects there. And this is basically what it came out to be. So standard search results with facets for the countries of the attendees. And then just to show off a little bit, I plugged in a jQuery component for creating a tree map and instantly had a visualization of the countries that was color-coded. So you know, that was a quick win there, and it just shows off how easy it is to get data in and provide a visualization. And also along those lines, I was able to use Solr's random sort capability in order to have a quick way to pick winners for our drawings. And so I did a very quick user interface for that, and that's all through what's built into Solr's velocity response writer, being able to create a template, leverage jQuery for an AJAX action, and then leverage Solr's random sort to pick a winner. I don't actually display I don't have on the slide here the winner stuff, but it's just a button that says pick winner, and then it pops back up the person's name. And then after I did that presentation, I did a webinar last year for our website, and I did the same titled presentation, but this time for a webinar, being that it was obviously a more business type setting there for the webinar. I wanted to bring in rich documents, so PDF, Word documents, any types of rich text documents. And Solr has built into it the extracting request handler, also known as Solr Cell. All you have to do is post a file in or point it at a file, and in this case you can see the generic curl command there where I'm bringing in a PDF file, and using the built-in user interface with a couple of tweaks to the configuration, I was able to display the content types as facets, and then had the general search results with highlighting in there, and also spell checking. You can see there's the did you mean as well, and that just comes basically out of the box with Solr. And then just again for fun, to add a little visualization, I put in a pie and bar chart component to show that same content type information, but in a visualization there. And then at ApacheCon last fall, I again did a presentation called Rapid Prototyping with Solr. This time I chose the US government's data.gov catalog data. They have a number of open data sets, and they have a catalog of their data sets that comes out as in a CSV format. And for that one, again, just used the update CSV handler and customized the user interface for the particular facets that made sense out of that data set, and made it look a little bit prettier, and voila, you get the full basic search interface there within literally a matter of minutes of being able to upload the data and then iterate on the user interface just slightly to get this effect. And also along with that comes built into the /browse interface in Solr is the ability to look at the debug information. So you can actually turn on the debug information, and when that is enabled, that search user interface gives you the ability to look at the explain information that comes from Lucid to see why that particular hit ranked the way that it did, why it scored the way it did given that particular query. So very easy to see right there within the search results the scoring information, the full calculation, as well as the query parser parsed information it gets surfaced there, and so you can just kind of turn those on and off at your leisure to investigate. And then next up was Ajax Suggest. We want to be able to, as you type, suggest some information, and you can see the little graphic there of the suggest. And what you see also in the code there is the URL that will return back literally just one line for each suggestion, just as a plain text output. And the way that gets generated is just through that small velocity template that is shown right there underneath. And that suggest is actually built right into that /browse interface as well. And then also, of course, to put a little bit of visualization to the situation and to play with some Venn diagrams here, I created another template and plugged in a separate request handler that pointed to that template and allowed the users to put in 3 different queries and then to use Google's visualization toolkit to generate a Venn diagram that showed where those hits overlap between those 3 different queries, and then at the bottom allow you to navigate to any of the combinations of those intersections there. And all of this really took just literally a matter of minutes to put some of these things together. All right, so in my procrastination, I started last Friday actually, just kind of poking around to figure out what data set I wanted to bring in for this presentation. And I figured I'd do something, again, business-centric here. I used the Best Buy open data set. They have an HTTP interface that returns JSON, and you can do some basic filtering there to choose different types of products. I did one basic filter there to choose products that were available online. And through that, I simply wrote a little bit of script here. I figured I might as well show a little bit of code in this presentation. This is a Ruby script. The heart of the code, the bulk of what you see on the screen there, is that mapping data structure that is showing the Solr field names. And on the right side, it's showing the data field names from the original data source that came back from the Best Buy API. And you can do a few different things in there, and there's one trick in there where you see that proc. That's the ability to execute a little bit of code to transform information as it comes in. In this particular case, the Best Buy data has a category path data structure, which is an array of category IDs and category names. And I simply joined all of the category names together and put a delimiter in between them. So that's my way of doing a little bit of transformation there. The rest of the mapping there is simply field name mapping, so that I can leverage. In fact, I didn't even change the example schema that comes with Solr 3.1. I used the dynamic fields, so that's why you see the _s, the _f, and the _t fields that are coming in there, because they're dynamic fields for string and text and float values. And so that's the bulk of the code to bring the data in there. Let me go back to this slide here. That very last line there is a little bit of Ruby magic that's built into the Solr Ruby library. And I just bring this up because, of course, it's a little bit of opinionated, but Ruby's a fantastic language, and I wanted to show off what you can do with this particular piece of code here. There is an indexer class within the Solr Ruby library. It takes 2 to 3 parameters. It takes a source and a mapping, and then optional options, and it's kind of slick. The source is anything that implements the pound each method, or the each method. So anything that you can iterate through becomes a data source. And in this particular case, I'm getting data back from the Best Buy API, and it's giving me back an array of results. An array in Ruby implements the each method. So all I had to do was pass exactly the data that I got back from the Best Buy API right into this, and it's going to iterate through each one of the results there. Now for the mapping, being able to take one result that it gets back from each one of those iterations through the pound each there, it needs to be able to get back a particular field or attribute from that data. And again, using basically what's called duck typing, or just kind of loose typing there, I'm able to just leverage Ruby's bracket operator and get back one field out of the data and bring it back. So this particular data lends itself very well to just mapping stuff straight in directly using this option. So it really only took one line of code there to iterate through the entire data source and map the products into Solr that way. The next step is to put some kind of user interface on the situation. I'm showing initially right here a project called Prism. This is just kind of a brainstorm that I've had for a while. It's kind of been collecting dust, but back in January I fleshed it out a little bit, enough so that it actually works and it's Ruby. There's actually another slide that shows us. I'm actually going to iterate through the ugliest interface to the prettiest interface, okay? So it's going to get a little bit better. But Prism right now, it's really just kind of a quick hack. It actually is out there in open source on our GitHub repository. It's in Ruby, because that's a beautiful language. It's built on Sinatra, not Rails. Just because I wanted something lightweight. Now, Sinatra is rack compatible, so it can actually slot into other Ruby web frameworks such as Rails. And templating-wise, it can actually leverage any of the Ruby templating languages. So you can use ERB, which is JSP-like, or in this case, I actually did a little bit of JRuby, so this is running in JRuby. I used velocity templating, simply because I think velocity templating lends itself very well for end users, somebody that doesn't really know, need to know ERB or JSP or any of this stuff to easily kind of change a template if you just know some basic HTML and just know a little bit of what velocity's templating is like. So it's very easy to pick this up. And it's designed to work with any Solr instance. So it sits outside of Solr, and you simply point it at whichever Solr that you'd like, and it makes the requests and then renders the result that way. Again, it's simply a proof of concept that's out there, but it's lightweight, lean, clean, and works. Next up is this thing called Solr Toss. It's what we've been seeing in the previous slides for the previous presentations that I've done this way. This is what's built into Solr in terms of search user interface. And out of the box of Solr, you can index its example data, and then you've got facets, search results, suggest, highlighting. I think there's even got some more like this in there, and then it's got the spell checking too. So all of these things are baked into the out-of-the-box experience with Solr's UI. Oh, it also has, now it has spatial integration. So if you click on the spatial link and you've indexed the example spatial data, you will get Google Maps with each one of the hits to see where they actually are on the map. So what is this thing, Solr Toss? Technically, under the covers, it is the velocity response writer. It's just another response writer, just like in Solr's default response. You get back in XML, you can get that back in JSON, and then you can use this writer type equals velocity, and it just takes the Solr response object and passes it into velocity templates. And you can very easily tweak those templates, hit refresh in your browser, and it's immediately visible, the changes that you've made. Unfortunately, the name Solr Toss looks more like a disease and people don't quite pronounce it properly, so I can't win every naming game here, so that's my one dud for naming something. But it is the velocity response writer, and it's built right into Solr, just Solr/browse out of the box of Solr 3.1, and there you go. You've got a search user interface. And again, it's very easy to edit any of the templates, put your logo in the upper corner, change the color schemes, whatever it takes to, kind of wow your boss, like, okay, I just took the data in this morning, I'm going to go out to lunch now, but here's your user interface, now what? Okay, so that's kind of the idea, and in fact we've used this particular technology in customer engagements in order to very quickly prototype proof of concept for people. Okay, so here's your data, here's what the facets are going to look like, and here's how you can implement certain features like suggest and those types of things. Okay, so here is that same data. I've got all three of these running actually right now concurrently, obviously all on different ports. So I've got the Prism, I've got the Solr Toss, which is coming straight out of Solr, and I've got Blacklight running. Now, Blacklight, as you can see, is the most attractive of all of the user interfaces that we've seen so far. It shows the facets, shows the search results. It has a number of other very interesting features, and I've got a slide that goes through that. It has authentication, so you've got user accounts. You can log in, you can save searches, you can bookmark search results, you can select items out of the search results, and then take those selected items and then export them. It's also a very customizable and extensible UI. It's built on Ruby on Rails, and it is actually out there in production in a number of systems out there. The most notable sites, and this is where the committers currently work in their day jobs, and it's at virginia.edu and also at stanford.edu, and it's driving the library user interfaces. So it does have a library-centric roots, but it is generic enough in that I was able to simply take the data that you saw me just index here and render these search results. I had to do a few little tweaks to its configuration, and I made one small adjustment to templates so that it would show the product images there. So it was one line I added to the detail template, and voila, I had that, and I had to do a little bit of configuration to tell it which facets I wanted to render and what fields I wanted to render in the search results. Okay, so that's Blacklight. 3 technologies for view, a number of technologies for being able to bring data into Solr very easily. You've got the CSV update handler, you've got the extracting request handler for bringing in rich text documents. Of course, you've got the Solr XML and the Solr JSON now to bring data in, and many languages operate on top of either of those update request handlers, so that there are many languages out there that have Solr APIs, very native Solr APIs, so that it's very easy to get your data into Solr through a number of different mechanisms. I prefer the CSV update handler if you can get your data into CSV. It's a very fast, clean way to get data in. And there's a few things that you can do to very quickly make your data searchable. These 2 lines that are shown right here under schema adjusting, you can make a dynamic field called star, and make that a string field, make it multi-valued. Now you can bring in literally any field name that you want without having to edit the schema any further. Every piece of data that you toss in it that's not already mapped as a fixed field name or some other dynamic field mapping will come in as a string. That doesn't make it very easily searchable, but it makes all of those values facetable at least. If you want all of that stuff to be full text searchable, now you just use a copy field of star to text. Now every field that you send in now is going to get analyzed, tokenized, indexed in a full text searchable way, and text is built into Solr's example schema so that you can, and it's set as the default search field, so very easily you can just do /select q equals whatever, basically any word that's in any of the text of the fields that you just brought in is now searchable. So then what do? Okay, now that you've brought this data in, you're going to iterate a bit. You're going to adjust your schema. You're going to do a little bit of analysis of your fields. You can look at Solr through a number of mechanisms. There is a schema browser. That thing actually is a JSON AJAX client that hits the Luke request handler within Solr to get its data. So both of those are driven off the same bit of data, and you can look at what all of the fields are that are now in the index. You can look at the number of distinct values in those fields. This will give you an idea of what happened during the indexing process, if it was tokenized, how many unique terms there are in those fields, and if it's a string field, you can see how many unique values are, so that maybe you want to pick certain ones to show off as facets. Not every string field is going to have a low number of distinct values, but the ones that have low number of distinct values lend themselves very well to being facet fields. And then, as I've said, there's a number of ways to display this information, and that /browse request handler definition that's built into Solr 1.4.1, Solr 1.4, as well as Solr 3.1. Easily allows you to see the search results literally right out of the box of Solr. So we got our data in. Now what? Is it the project done? If you've dropped it into any of these things, it looks pretty enough, your boss is going to say, okay, now put it into production, right? So you need to step back and say, now wait, we need to take care of business here. We need to do some more automation. We want to script that indexing process, complete full indexing run capability, as well as any kind of incremental or delta indexing that makes sense for your data. So get that automation going basically from day one. Work with real users, find out what they're actually going to do with the system, what are their search needs, what are their display needs, and work your way backwards. Look at what they want to be presented and work your way backwards into the schema design, into adjusting any of the configuration that needs to be made to facilitate that end result, because that's the ultimate goal there. And then of course you're going to have to iterate on your schema, enhance the schema. Generally you're going to be messing around with the full text fields and the analysis process, and customizing any of the tokenization and the token filtering that goes on for the full text fields, that sort of thing. Adding in custom spell checking type things, setting up what fields you want to highlight on, what fields you want to spell check on. All of those types of things require obviously attention to detail and a bit of drilling down and messing around with the configuration. And then of course you've been playing around on your laptop and you've got the prototype up and running, but what you really need to do is get that thing out into some kind of staging environment, and then ultimately to production-like environments. It's very nice and easy to work with a sample of data. I just worked with 10 records until today, and I kicked it up and I've got, I think, 10,000 records in there now. But a lot of problems surface as you grow and start pushing to scale. Things like the amount of memory that you're going to need for faceting and for sorting, those sorts of things aren't going to rear their ugly heads until you are at scale. So start pushing the systems to scale in terms of the collection size, in terms of making sure that you're doing real world queries there. Sometimes as developers, we have our common search string. I type the word search into all the search boxes that I'm playing around with just to see what happens. But those aren't real world queries. You need what people are really going to be typing in. If you've already got a system, start mining your logs, get those query logs and start pushing those into the system. Of course, query volume is going to matter. Are you going to be able to handle what your real load is going to be? Start pushing that. And then, of course, ultimately, the system that Solr is running on is going to matter. So JVM tuning and hardware. Again, all of these things require going to scale to really seeing where the edge cases are of the problem. My final slide really here is about testing. I would be remiss to not talk about that. Very important to get performance testing going, scalability testing, relevancy testing. All of these things will help you as you iterate through your system and build this thing out to ensure that you add another sort field, that your system doesn't now break because it blows up the JVM's memory allocations, and that you are pushing in the right amount of documents, not pushing in more documents than it can handle, and if you are, adjust to be able to handle that. And then of course, ultimately, relevancy really matters. And it does take tuning to get that right in terms of making sure you're querying the right fields, you're boosting properly, you're using your function queries. All of those types of things really demand that we put in some form of testing so that we're not just hoping that our configuration tweaks as we push them from development into production are going to do the right thing. And also with testing, testing's great as one-offs. However, automate those tests, set it up so that they're running every time you deploy or constantly or whatever makes the most sense. But start getting that testing going as soon as you build the app. Get those baselines for performance, avoid regressions. One of the interesting stories I've heard about that particular thing about avoiding regressions is Apple and the Safari browser. I've heard that as they were building that, of course they wanted it to be the fastest browser around, and they actually had a process such that when a change was committed to the code repository, if it made the browser any slower on any of their tests, that change was actually rejected. So you weren't allowed to go any slower than it already was. So that's avoiding regressions in that sense. And I know done quite early, this is rapid prototyping. This is the end of the slides. I'm going to pop over and actually show these systems working that I just demonstrated. Okay, so here's the ugliest of all the user interfaces that I had. This is the Prism. And so I can put in other search terms here, such as, I'm not sure what else I'll find here. I haven't really tried various searches here. Find various things. So I'm just changing the Q parameter in the URL to search for various things. And I can actually tell it what template I want it to render. And so over here in the Prism directory, there is a directory of velocity templates here, and I can simply change one template over here and just put in whatever I want and hit refresh, and then every template changes like that. So very easy to adjust some of these things. The one tweak that I made was this one line here to put the image in there. So I took the document object and rendered the thumbnail _s, which means string, in an image tag, and that's what puts those these images out there. They're not actually all available there from Best Buy, but there we go. Okay, and so that is the Prism user interface. This is the Solr Toss, the velocity response writer interface. This is so I can search for something and then facet on things, drill into that, remove facets. It supports the range faceting here. So if I search for *:*, oops, my suggest actually overrode me there. And *:*, and see I can see the price range facets. And I can come down here and click on Enable Debug. And then if I query for a particular term, I now have this toggle explain. I can see why that hit ranked where it did. I can see what query parser effectively is in use here and what happened to this particular search term. You can see the suggest popping up there in the search box. It's got paging through the search results. And so lots of bells and whistles in there. It actually has highlighting as well. I don't think there's really anything useful to highlight in this particular data. And so that's the velocity response writer. Here is Blacklight in action. I can remove particular search terms. I can see the facets. It's got some nice UI effects. I can drill into particular facets here, and I can bookmark particular items. I can actually select a couple of items, and then I can come over here and see my selected items. And because this is a library-centric user interface, again, it is configurable. It's got a lot of library-specific kind of exports in there, but I can export this thing to third-party systems. I can look at my search history. I have an account in here, so I can log in and save my searches over here. Okay, and clear your saved searches, and basically come back to the main interface here. Now they have the default in Blacklight is to actually not show the facets, and that's because in a lot of library data there is a ridiculously enormous amount of values in various subject heading fields, so it would be overwhelming to see a lot of that. So it's got the expando type stuff in there. And then so those are the three kind of quick and dirty user interfaces, and it really took almost nothing to get these things up and running. You know, a few little tweaks to some configuration and templates to make this stuff come out. I was able to adjust the header for this particular thing, and also the title of the page, and all of those things just come out very easily. This is the velocity response writer stuff is over here under your Solr directory. Under the configuration directory, there's a velocity directory, and so you can edit the layout over here. So I can say and simply refresh, and whatever I put there comes out. This velocity response writer has a number of bells and whistles in here for being able to even override the template externally. So I think I could say v.template. Let me see what it's called. The hit template. Just change it to something dumb. And so I've actually overridden the template from the request. That could be helpful in some cases there. So there's a lot of different little clever things that you can do to play around with this data. It's time to open up for questions.
I'm going to make available if you accept the files. I mean, you give it to us for the training, but you're going to make it available. So we can download the files, save all the what you did, play around with it, and place and all that.
Well, the templates, the velocity stuff is already in Solr. Yeah. So that's already there. Prism is, it's just a dumb little proof of concept thing that I tossed out there. It's on our Lucid Imaginations GitHub. And Blacklight is at projectblacklight.org. So there's the URLs to this here. I think for the Prism thing, I put that on the slides as well. So all of these things are available.
It's already there. When I download Solr on my hard drive, it's there. The velocity template.
Yes. Yep. And that's all built into Solr. So those velocity templates for that are right there. Yep. So in the training, that really was just Solr 3.1 that we used.
Two questions. First one, how did you get the effect of exporting selected data in Blacklight? Can you do that in Solr Toss as well? And question number two, can you do geospatial search based on zip codes?
Okay, first question, how did the selected item export stuff work in Blacklight? Blacklight is a Ruby on Rails application, so that is handled at the application tier, not related to Solr at all. They're just letting you click on things there. You can see over here as you click on items. Up here it tells me how many items are selected. I can clear my selected item somewhere. I can just say uncheck this particular thing. You can see that count actually changes over here. So they've got a lot of really cool things, but that's completely at the application tier. So they're taking that list of items and providing some code that exports it to a number of different formats. The second question was about zip code, geographic stuff. No, not out of the box. You don't get any kind of zip code geo proximity information. Certainly that could be something that you could augment your data with if you had probably the center of that particular zip code from the US Postal Service and augment your data with those geo points, then you would have that tagged to your data.
Not really a Solr question, but I was wondering why you preferred Solr Ruby over RSolr or Sunspot.
Well, I wrote Solr Ruby, so kind of opinionated. I'm actually good friends with Matt Mitchell, who is the author of RSolr. We're Rubyists. We're all very opinionated, so we do everything. I would think if I had to do it over again, there's only Solr Ruby is a bit overkill. There is too much stuff in that. It really doesn't take much to interact with Solr from Ruby. And in fact, within LucidWorks Enterprise, we have a Ruby on Rails based search user interface. It's not using any of these particular technologies, but ultimately we are using code. I think I just actually copy and pasted the code over here into Prism. But there's really, that's the code that it takes to interact with Solr. There's nothing to it. And in fact, it's really just this. This other function is just to make the URL encoding of the parameters. So I don't know, just like to make things lighter weight. But the Solr Ruby, again, it's just got that one really interesting feature that I like, and that's this Solr indexer that allows you to iterate through anything that can give you back successive objects, and that can take the bracket operator, which a hash does, so that in this case the reproducts is an array of hashes. So it's each one is giving back a hash, and then when you use this mapping, each one of those hashes supports the bracket operator. So under the covers, it's doing the object that's returned back, bracket that symbol, and getting the data back. So I think I would probably kind of throw away Solr Ruby. RSolr is fine, and then keep this little mapping indexer stuff around. Well, I appreciate your time today, and be happy to socialize with you guys tonight at the party, and I guess now we're going to take a little break and try to stump the chump. Thank you.